What's up, guys? In my last video, I talked about training AIs to play video games. Specifically, I trained an AI to play Atari Space Invaders using a DeepQ network. For today's video, I wanted to step it up a notch. Instead of basic Atari games, I wanted to try something a little more challenging. Sonic the Hedgehog for the Sega Genesis. I could have went through the same Q learning process I did with Space Invaders, but what's the fun in that? So I decided to use a new algorithm called NEAT. While Q-learning is modeled after human learning, NEAT is modeled after human evolution. We essentially take a population of Sonics and have them run through a level. The best of those Sonics breed to create a new, stronger population of Sonics. This process continues until we have a Sonic that is able to beat the level. Sounds neat. Let's take a look at my Python implementation. Although I won't be going through every single line of code, I have a link down below in case you want to check it out. Accompanying our program to train Sonic, we have these two crucial JSON files.
The data.json file contains information about our game, for example, Sonic's X position and Y position. We will refer to these variables later to determine how well Sonic is performing. The scenario.json file allows us to alter reinforcement learning specific variables in accordance to our game variables. For example, we can say that Sonic is done playing after his lives hit 0, and he gets a reward of 10 for every pixel he moves farther right in the game.
Think of our config feedforward file as an options menu for our training.
In here, you will find a bunch of different parameters that you can mess around with to get different results. Some notable ones are fitness threshold and population size. They refer to how much reward our winning Sonic should get and how many Sonics are in each generation. If you want to go even deeper, I would highly suggest reading NEAT's documentation, linked down below.
For the moment you've all been waiting for, the code that trains our Sonics.
We start by importing our libraries and setting up our game environment and state. We create the function eval_genomes, which is used to evaluate how fit our Sonics are. For each Sonic, we will reset the environment and perform a single random action. We also reset genome-specific variables such as current max fitness, fitness current, frame, and more. While the Sonic is still playing the game, we will visualize our environment, start counting the number of frames, and save a one-dimensional black and white copy of the screen to feed to our neural network. We proceed to feed the image to our neural network so that I can predict the best action to take, and then we evaluate for the new screen, rewards earned for taking that step, if we have completed the game or not, in our game variables found in data.json. Lastly, we check to see if Sonic is done. We take its X position from the data.json file and see if it exceeds the length of the level. If it does, we reward Sonic the amount equal to our fitness threshold. Otherwise, we add the reward which was evaluated earlier. If Sonic has beaten the level or taken 250 actions, we finish training. We exit the eval_genomes function and finish off by setting up our config feedforward, printing out some stats to see how Sonic is doing, and save the winning Sonic into a pickle file.
And that's all there is to it. You can start training Sonic, and as generations go by, we'll create a super Sonic that can beat the level. I hope you guys learned a lot, and if you have any questions, feel free to leave a comment down below or shoot me an email. Until next time.